Hello. So this is a pretty insightful problem. A ball is thrown toward a cliff of height h. So this is the height. With a speed, so it's going to be thrown from here with a speed of 30 meters per second. So that's the initial speed. And the angle with the horizontal here is 60 degrees. And it's going to land, so it looks kind of like that. The ball is going to land over here at the edge of the cliff in 4 seconds. So we have to answer a few questions. The first one, how high is the cliff? The second one, what is the maximum height of the ball? And the third one, what is the ball's impact at speed? Sorry, ball's velocity, ball's impact speed, ball's velocity at impact. Okay, so the first, okay, I'm going to write this again over here. So the initial velocity, 30 meters per second. The change in the time is 4 seconds. And the angle is 60 degrees. And h, the height of the cliff, is one of the things that we want to calculate. So the first thing that it's important to notice and realize in this problem is that it's parabolic motion. So we have motion in y, motion in x. They're independent. We have gravity acting in the y direction. We don't have any force acting in the horizontal direction. So let's get the initial velocity in x, because it's a 60-degree angle. It's going to be, we want the x component. We can use the cosine of 60. So it's v initial cosine theta. So this is cosine of 60. And so if we want a numerical value, it's going to be .30 meters per second times 1/2. It's cosine of 60. So it's going to be 15 meters per second. And we can do the same thing in the y direction. So the initial speed, now it's sine 60. So sine 60 is 0.8660 times the 30 meters per second. It's going to be 26 meters per second. Okay, so we have the x component of the initial velocity and the y component of the initial velocity. So the first question is, how high is the cliff? And so for that, we can use this kinematic equation. And notice that How high is just the y direction, right? There's no x component, so it is the same equation, but we don't want to get confused. So let's put the y in here. It will be the initial velocity in y. This will be the acceleration in y. So let's say that the initial height is 0. So we want to know this y, right? It's going to be 0 meters plus the initial velocity in y. For let's first write the most general equation. It's going to be v naught sine theta times the time plus the acceleration in y is going to be negative. It's going down 9.8 meters per second squared, right? So it's going to be minus 1/2 of g t squared. And we want to know, this is a function of the time only. And we are told that it takes 4 seconds to go there. So let's rewrite this in a way that is hopefully not too confusing. So the position at 4 seconds, we can put the 4 seconds in here too. And here too, right? 4 seconds squared. And so, let's rewrite the whole thing. This quantity is 26 meters per second times 4 seconds minus 1/2 of 9.8 meters per second squared. This is 4 times 4, 16 seconds squared. The seconds squared go away, we have meters, and the seconds here go away, we have meters. So this is going to be 26 times 4, 104 meters, minus this one is going to be 9.8 times 16 divided by 2. That is 78.4 meters. And so the position at 4 seconds is going to be 25.6 meters. And so that is going to be the height of the cliff. So the first term is the height that it will have without gravity. So with this initial velocity, if you didn't have anything pulling it down, the height will be 104. But at the moment that it starts moving up, it starts falling. And so this is the distance that an object will fall, any object will fall in 4 seconds. And so the difference gives you where that ball is located in the y direction. So it's 25.6 meters. So let's write it down over here. This is the height. Then we are asked what was the maximum height of the ball. And the easiest way to get that is with this other kinematic equation, right? The velocity squared is equal to the initial velocity squared plus twice the acceleration times the displacement or the distance. But for this, it is not given that, but you're supposed to know it, that the velocity at the very top is 0. So the final velocity over here is 0. The initial velocity, it's initial velocity sine theta. So the acceleration is just the acceleration due to gravity. And we're looking for this distance, the maximum distance. So it's going to be v squared minus v naught squared divided by twice the acceleration. And that is the distance. So this is 0. So it's going to be 0 minus the initial velocity is the initial velocity in y, because this is still vertical motion. So v naught sine theta divided by twice the acceleration due to gravity. So minus 2g. And this is a minus because acceleration due to gravity is pointing down. Okay, so this 0, we can forget about it. And then we have minus and minus. We can forget about them too, because minus and minus is plus. And notice that this equation is completely general. This gives you the maximum height with any angle. Here we're looking for sine 60 in particular. So we can plug in our numbers there. So it's going to be 26 meters per second divided by 19.6 meters per second squared. Oh, this one is squared. I forgot about it. Sorry about that. Squared over here. Okay, now it makes sense. It was not making sense before. So this one is 676 meters squared, second squared. And this is the 19.6 meters per second squared. So the second squared go away. One of the meters goes away. And the units are meters, which is what we wanted. And so we can just do that division. We get 34.5. Meters, that's it. Okay, so I'm gonna call these Y max. $34.5 meters. Okay, and then finally, we have to calculate what is the ball's impact speed. And so for that one, we need to know the components of the velocity in x and in y. The component in x is not changing, there's nothing changing it, but the component in y is changing all the time because you have acceleration. So for this one in particular, we can use the velocity is equal to the initial velocity plus acceleration times time. We know the initial velocity. Well, actually, this one is going to be, well, this is the general, but we want the y component. I'm going to write it again. So the velocity in y is the initial velocity in y plus acceleration in y times the time. So this one is the initial velocity sine theta. And this one is going to be minus g times the time. We know the time is 4 seconds, the time that it took for the ball to impact or touch the edge of the hill. And let's write the version for the x component. So again, we have this equation. So this one is going to be initial in x plus acceleration in x times the time. But we know that the acceleration in x is 0, so this whole term goes away. And we know that the acceleration in the x component of the acceleration is v initial cosine theta. And we know this number, it is the 15 meters per second. The one for y is going to be 26 meters per second minus 9.8 meters per second squared times the 4 seconds, right? So this second goes away with one of these, and we have meters per second, which are the units that we want. And so this is 26 meters per second minus 39.2 meters per second. So the y component of the velocity is minus 13.2 meters per second. And this makes sense, right? Because it went up 34.5 meters, and then it started going down to 25.4 meters. And so the velocity is in the y component of the velocity is in the negative direction. So we have the y component of the velocity and the x component of the velocity at impact. So if we want the magnitude, the ball's impact speed, then we need the magnitude of these two vectors. So I'm gonna write that one over here before I forget. Dy at 4 seconds is negative 13.2 meters per second. And for x is the same the whole time. And so we have the two components of the vector. To get the magnitude, we just use Pythagoras. So it's going to be that. So it's the 15 meters per second squared plus the negative 13.2 meters per second squared. And notice that the negative is going to go away because this is squared, which makes sense because this is a magnitude only. So then this is square root of 225 meters squared second squared plus 174.2 meters squared second squared. So if we add them, it's going to be square root of 399.2 meters squared per second squared. So the square root is going to take care of the squares over here. So our units are meters per second, and square root of 400 is 20. So this is 20 meters per second. And so that is the velocity, the magnitude of the velocity at impact at 4 seconds. It's 20 meters per second. Right? So we used all the concepts that we have learned about kinematics. So the velocity is 0 at the turning point. the height is maximum at the turning point. We can get the magnitude of a vector with the Pythagorean theorem. So the squared, adding the square of the components and taking the square root. And we also got the components in the x and y direction using trigonometry, so cosine and sine in this case. So yep, and we use all three kinematic equations. So a very complete problem. Thank you.